Good morning, boys and girls, the candidates of this year. Fortunately, we have lost one academic year, but that does not keep us away from books. Today, I have made a lesson for you, and I know you're going to enjoy it. Welcome to science. Now, today we are talking about making work easier. As you can see on the board, making work easier. And I want us to really look at beam balance and a seesaw. There is a close relationship between beam balance and the seesaw. Now, we want to first of all, look at the facts about balancing on both the beam balance and the seesaw. Are we together? Now, you can see that diagram. Look at it and study it. Look at the parts as they are labeled and be able to understand them. I know you did this in class 7, and that is why I want you to look at it and understand the positions of the load, the fulcrum, and the effort. You learned it under the levers. But today I want us to look at the beam balance here. Now, balancing happens. Balancing happens when, one, the distance between the load and the pivot, which is called the load distance, LD in abbreviation, is equal to the distance between effort and pivot. That's called effort distance, ED in abbreviation. When they are equal, the masses can balance. Number 2, when the load has the same pull of gravity with the effort E. Pull of gravity. What is pull of gravity? Weight is the pull of gravity on a substance. So when they have the same mass, they'll have the same weight. And that would be the pull of gravity on a substance, and that is weight. Remember, mass is the amount of matter contained in a substance. That is mass. That's how we describe mass. But weight is the pull of gravity on a substance, on matter itself. Number 3, when the position of the heavier load is placed near the fulcrum, nearer the fulcrum than the lighter load. When it's placed nearer the fulcrum than the lighter load. That means the lighter load moves far away from the fulcrum and the heavier load moves closer to the fulcrum for them to balance. Now let's study this diagram once again. Now, on this diagram, this is the load. And the load distance is the distance between the load and the fulcrum. The fulcrum is the pivot. So fulcrum is the other name of the pivot. Fulcrum. Thank you. The midpoint. The fulcrum must be placed in the middle, at the center of the balancing plank. That is the balancing plank. You can see I've marked it so that you understand the positions. Now, so the distance between this load, this point, and here, the fulcrum, that is what you call the load distance. That is the load distance. Likewise, the distance between the effort here and the fulcrum, that distance is known as the effort distance. I hope you understand that. Now you know the positions on this balance. And you know the facts about balancing. We can be able to answer question number 40 of 2012, Kcpe 2012. For two masses to X and Y, the mass of X was twice that of Y. Twice. I underline the word twice. That means X is twice as heavy as Y. That means if Y is 10, then X is 20. I hope now you understand that question. Now, the diagram below shows a setup that was used to investigate how the two masses balance at positions Q, R, S, and T on a seesaw like this one. This is the seesaw. Doesn't it look like this balance as the seesaw? And you can see the labeling of the positions clearly. Now let's look at the question. Which of the following was a correct observation about the investigation? Now look at that. It's an observation. They want us to find the observation. The one that carried out the investigation observed something. Now, in an activity, there is the aim of the activity. And then there is the procedure. First of all, the aim, then the apparatus, then the procedures, and then observation and conclusion. 5 things, boys and girls, mark this. The aim of the activity, the apparatus, these are the materials used to carry out the activity. The procedure, that's the methodology. The observation during the procedure. And then the conclusion. Then the activity is over. And so here we are asked to find the observation. So what did we observe? Observation is so literal, it's so practical. But when you're asked to find the aim, what were they investigating? That's an aim. Yeah, what were they investigating? That's an aim. If you were asked, yeah, what is the conclusion? The conclusion. If you're asked about which materials was placed wrongly, that's about the apparatus. Yeah. What did they do wrongly? That's about the procedure. So several questions can come out of an activity like this. And so here we're asked to find an observation, boys and girls. If mass X and Y were placed at position Q, X was placed at Q, and Y was placed at T. Let's look at this. Let's place these masses, X at Q, we place here X, and Y at position T, and Y at position T. Putting in mind their masses are different. Yeah? X is twice as heavy as Y. And from my preamble, I said the position of the heavier load is placed closer or nearer the fulcrum than the lighter load. X is heavy. X is heavy. X is heavy. It's far. It's placed at the same distance. Actually, the same distance. 1, 2, 1, 2. Same distance as Y. And the two do not have the same mass. X is twice as heavy. That is obvious that the heavier one will move down. The heavier one will move down. So in this case, it's correct to say that this side will move down and this one will move upwards. Let's look at, if we place X at R and Y at T, X at R, let's look at X at R and Y at T. Y remains at T. Now, X is heavier, has moved closer to the fulcrum than Y. That is obvious. They will balance. Here, they will balance. Let's analyze that. Yeah? Here, they will balance. Here, balancing will take place. Here, balancing must take place. They must balance. So this is wrong. Moving up, that is wrong. Q, X at point Q. Where is Q? There. And the Y at S. Let's place y at s. Y at s. Now, y is lighter. It is now closer to the fulcrum than x. What do you think? A lighter object, lighter mass, is closer to the object. That means it will still be displaced upwards. It will be displaced upwards. So here we will observe it being displaced upwards. So y, point V. V move upwards. Alright? And P downwards. Let's come to D, choice D. X at position R and y at S. R and they are at equidistance. Boys and girls, say equidistance from the pivot. Equidistance from the pivot. That means they are placed equally, at equal distances. That means the heavier object will still move down. So V will move up. V will move upwards, not downwards. Upwards. Upwards and not downwards. So this is wrong. Now let's analyze A. A says that P moves upwards. P moves upwards. A says and P moves upwards. And P is this way. And we're placing X at Q and Y at T. X is heavier than y at t. And P moves downwards. They are equidistant. Remember that? They are equidistant. They are equidistant. So the heavier one must move down and P moves down. And that is correct according to that. Boys and girls, consider the reasoning that I have engage you here in this question and consider these facts and you come to a conclusion. And so the right answer here is A. Choice A is correct. Let's look at a similar question in Kcpe 2017, question number 35. More facts are coming about this. The diagram below illustrates two candles balancing against one. If all the candles are lit at the same time, which one of the following is a correct observation? Again, they want us to look at the observation made in the experiment. Here, have asked the same question, observation. Let's look at certain other facts. The pivot or the fulcrum is at the center or at the middle of the beam balance or the seesaw. One candle on this side. Look at this. The placement of this candle and the placement of this candle is the same. Yet there's another inner candle. These candles have the same masses each. So this side has heavier mass than this side because of the two candles. But look at this fact. When matter is heated, when matter is heated, look at the following facts. When matter is heated, one, it expands. Matter expands on heating. Expands. That is one. Some matter change their states. So we say solids, solid matter and liquid matter change their states. That is a fact, boys and girls. Number two, when matter is heated, its mass increases. Its mass increases. And this is the fact I want us to work with. You can Google and you'll find that when matter is heated, its mass increases. There are things that change when matter is heated. Shape changes. mass changes, volume changes. Let's look at that. Shape, mass, and volume must change. All right? Another thing is the placement of this. When this one and that one are placed together, they balance. There's one that is placed here, inwards. That means closer to the pivot. And we say the heavier load is placed nearer the fulcrum. So this side is heavier, and so it has been moved closer to the pivot to balance. So at this point they are balancing. They are balancing. They have said if all the candles, they have said illustration illustrates two candles balancing. That means the apparatus is balancing against one. Look at the application. Now, let's look at that and considering the reasoning and the heating. The two candles were displaced upwards. Were they displaced upwards? That means this one became heavier than that? I don't think so. The single candle was displaced upwards. If this one became heavier, then this one also became heavier. There was no change in the setup. There was no change in the setup. Let's put that one aside. Then the seesaw will swing towards both the sides. The seesaw will swing towards both the sides. Let's look at these facts here and consider this. Boys and girls, let's look at those facts and consider that. And then we come up with the right answer. Now, here, we want to say that the single candles, that's what the Kcpe gave us as the right answer. The single candle, not candles, the single candle was displaced upwards. How is that true? Lit at the same time, yet they were balancing. How is that true? If they were balancing, that means the positions was not changed. According to that argument, then there was no change. There was no change. But Kcpe gave us B. But according to these arguments and the facts, the answer is C, boys and girls. We look at the right one. We are told that the mistakes done by Kcpe are incorrigible. And so if they give a wrong answer, it remains wrong, a wrong correct answer. Boys and girls, let us consider the fact when you're answering science. Science requires reasoning with facts, brains working, with understanding of the setup, especially the experiment. And I'll say you will be tested, especially on this activity. Either on the aim, being asked what were they investigating, you will be tested on the apparatus. Either you name the materials required and the amounts, the measurement, the standards, or you will be tested on the procedure, which step was wrong, was it in the right order, or what did they observe, that's observation, and what did they conclude. Expect 5 questions, each per paper. So if next year they will ask about activity, one of them. They are fond of asking observation, but don't discredit the other questions that would come. Thank you, boys and girls. I enjoyed teaching you. Science is life, and we can always learn science and enjoy science. God bless you. Bye.